Hi everyone, welcome to our physics class. In the previous class, we have studied about velocity and different types of velocity. So velocity means displacement per unit time or the time rate of change of position along a fixed direction. So the different types of velocity are the first one is the average velocity. That means the ratio of total change in displacement to the total time taken. The second one is uniform velocity. So when a particle is said to be moving with uniform velocity, if it covers equal displacements in equal intervals of time. And third one is non-uniform velocity. That means when a particle is said to be moving with non-uniform velocity, if it covers equal displacements in unequal intervals of time, or unequal displacements in equal intervals of time, or unequal displacements in unequal intervals of time. The last one is the instantaneous velocity. That means the velocity of a particle at any instant of time. So what are the main differences between speed and velocity? Speed is the distance covered per unit time. Velocity is the displacement per unit time. Speed is always positive. Velocity can be positive or negative or zero. Speed is a scalar. Velocity is a vector. So those are the main very important differences between speed and velocity. So this is motion along a straight line, part 4. Okay, well, let's start today's class. Today we are going to discuss about some very important numericals, how to solve very important numericals. So in the previous class, we have already completed one numerical. So this is the second numerical. Find the velocity of the particle per the time interval t is equal to 5 second to t is equal to 10 second from the following graph. Okay, now look at this graph. So in this graph, let us consider this point as A and this point as B. So A and B are 2 points on a straight line. So here, what is the initial displacement of a particle? So the point A corresponding displacement is x1. So x1 is equal to 10 meter. Actually, this is the initial displacement of the particle. And the point A corresponding time, that is 5 seconds. Let us consider this one as t1. So this is initial time of a particle. So this is the initial displacement. So the point B corresponding displacement, let us consider that is x2. So this is the final displacement of a particle. And the point B corresponding time, let us consider that is t2. So this is the final time. Okay. So actually here we have to calculate the average velocity. So what is the mathematical expression for average velocity? That is a ratio of change in displacement, is x2 minus x1 divided by the change in time, that is t2 minus t1, right? So here x2, that is 20, x1 is 10. So 20 minus 10, so that is in terms of meter. And here T2 is 10, T1 is 5, 10 minus 5 seconds. 20 minus 10 is 10 meter. 10 minus 5 is 5 seconds. 5 1 0, so 5 2 0. So the average velocity of a particle is 2 meter per second. So this is the average velocity of the particle. Okay, the next numerical. This is numerical number 3. An automobile moves at 40 km per hour for 3 km and at 50 km per hour for the next 3 km. Find the average speed of the automobile. So here we have to calculate again the average speed of the automobile. So what is a mathematical expression for average speed? Average speed is total distance traveled by automobile. Total distance traveled by automobile divided by total time taken. Okay, so here the total distance is x1 plus x2. So total time, that is t1 plus t2, right? So what is the total distance? Total distance traveled by the automobile is x1 plus x2. So here, what is the value of x1? That is 3 km. What is the value of x2? That is also 3 km. Okay. So total distance traveled by the automobile is 6 km. So this is very simple calculation. So after that, we have to find out what is the time taken by the automobile to travel the first 3 km. Okay, so here we have to calculate T1. Actually here the speed of automobile for the first half of the journey is given, is it not? So the time taken by automobile, for first of journey, that is T1 is equal to, actually speed is distance divided by time. So time is distance divided by speed, is it not? So T1 is x1 divided by v1. So v1 is the speed of the first of journey. So x1 is the distance covered in the first of journey. So the distance covered in first of journey is how much? That is 3 km, right? Speed of the automobile in the first of journey, that is given 40 km per hour. 40 km per hour. Kilometer get cancels. Okay. So 3 divided by 40. What is the value of 3 divided by 40? 3 divided by 40 value is 0.075. What is the unit? Not second. This is an hour. 0.075 hour. Okay. So then the time taken by automobile per second of journey, per second of journey. So that is T2 is equal to, what is the expression? X2 divided by V2. So X2 is 3 kilometer. So V2 is the speed of automobile in the second of journey. So that is given how much? 50 kilometer. 50 kilometer per hour. 50 kilometer per hour. So kilometer get cancels. So 3 divided by 50. What is the value of 3 divided by 50? 3 divided by 50 value is 0.06. What is the unit? Hour. Okay. So average speed is equal to total distance traveled is that is 6 kilometer. Total time taken, that is 0.075 plus 0.06, right? 0.075 plus 0.06 hour, that is taken as common. So average speed, that is equal to 6 kilometer divided by 6 kilometer divided by, so 0.075 plus 0.06 value is 0.135. This is in terms of hour. So 6 divided by 0.135, that is 44.444. 6 divided by 0.135 value is 44.444. Okay, so this is the average speed of automobile. What is the unit? Kilometer per hour. So the average speed of the automobile is 44.444 kilometer per hour. Okay, so the next problem. This is numerical number 4. A cyclist goes up a hill. A cyclist goes up a hill at 3 kilometers per hour and down the same hill at 6 kilometers per hour. 6 kilometers per hour. What is the average speed? Okay. First here, let us consider h be the height. H be the height of the hill. Okay. So what is the total distance traveled by cyclist? This is very simple calculation. The total distance traveled by the cyclist is, he goes up a hill and down the same hill. So h is the height of the hill. So the total distance traveled is h, right, plus h. So that is 2h. A cyclist goes up a hill at 3 km per hour, so covers a distance is h, and down the same hill at speed is 6 km per hour, but the distance covered is same, that is h. So the total distance traveled by cyclist is h plus h, that is 2h. So average speed is the total distance divided by the total time. Is it not? Total distance divided by total time. So here we have to calculate what is the time taken. What is the time taken by the cyclist to goes up? Okay, so time taken by the cyclist to goes up, that is t1 is equal to, what is the formula? Speed is distance divided by time. Time is distance divided by speed. So t1 is equal to x1 divided by v1. So x1 is h. So v1, that is given. Okay, v1 is 3 km per hour. v1 is 3 km per hour. Let us consider, so this is h kilometer. Okay, so this is 3 km per hour. So kilometer get cancels. This is h divided by 3 hour. Better let us consider capital H with the height of the hill. This is h plus h. This is 2h. This is h divided by 3. This is h by 3 hour. So capital H is the height of the hill, small h, that is hour. Okay. So after that we have to find out what is the time taken by the cyclist to go down, right? So the time taken by the cyclist to goes down is t2 is equal to x2 divided by v2. So x2 value is h divided by v2. v2 is 6 km per hour. This is h, capital H. x2 is capital H divided by v2 is 6 km per hour. This is h kilometer, so kilometer cancels. This is h divided by 6, h divided by 6 hour. H divided by 6 hour. Okay, so average speed is equal to total distance traveled is 2h, total time taken, that is 2 capital H. Total distance traveled is 2h. Total time taken is h by 3 plus h by 6. This is in terms of hour. So this is in terms of kilometer. Okay, total distance is h plus h kilometer plus h kilometer. So this is 2h kilometer. So average speed is equal to 2h kilometer divided by h is taken as common here, 1 by 3 plus 1 by 6 hour. So h cancels. So 2 divided by, so what is the LCM? LCM is 6. 3 ones are 3 twos are 2 plus 1, right? This is kilometer per hour. So 2 divided by 2 plus 1 is 3 by 6. Okay, so 3 ones are 3 twos are. So 1 by 2, that is shifted to the numerator. What happens? 2. 2 into 2 is 4. 4 kilometer per hour. So this is the average speed of the cyclist. So the average speed of the cyclist is how much? That is 4 kilometer per hour. Okay, the next numerical. In 1 second, a particle goes from point A to point B, moving in a semicircle of radius 1 meter. Find average speed and the magnitude of average velocity. So here we have to calculate average speed and the magnitude of average velocity. Okay. So first here, let's consider semicircular path. Here the particle travels from where to where? Particle travels from A to B. So this is the center of the circle. So here particle traveling from where to where? Point A to point B. That is moving in a semicircular path, and this path of radius is 1 meter. So we have to calculate the average speed. So average speed is equal to total distance divided by the total time taken. Okay, so here particle completes the semicircular path. So what is the distance covered by the particle? For one complete rotation, that is 2 pi r. So for semicircular path, the distance traveled is just pi r. Is it not? For complete rotation, 2 pi r. Off rotation, that is just pi r. So what is the time taken by the particle to complete the semicircular path? That is 1 second. Okay. So what is the value of r? R is 1 meter. So this is 1 meter. This is 1 second. So finally we will get pi meter per second. Pi value is 22 divided by 7, right? That is approximately 3.142 meter per second. What is this? Average speed. This is the first part. So after that, we have to calculate the magnitude of average velocity. So average velocity is the total change in displacement. Displacement divided by time. So here, what is the displacement? Displacement is the shortest distance between initial and final position. So here A is the initial position, B is the final position. The shortest distance is AB. So AB is OA plus OB, that means R plus R, that is 2R. R is the radius. Time is 1 second. So this is 2 into R value is 1 meter divided by 1. So this is in terms of meter, this is in terms of second. So the average velocity is 2 meter per second. So this is average velocity. The average velocity is 2 meter per second. So what is this? This is average speed. Average speed is 3.142 meter per second. So the average velocity is 2 meter per second. Okay, thank you.